like 45 at like quarter till the hour. So it would be good that you're recording it.
Okay, you know what's funny is a voucher recorded it.
Yeah, now I recorded it, but through the room, not through my account, through the room.
Okay, weird. Okay, anyway. Well, okay, welcome everybody. I'm glad to see some old faces and new faces. Hello, hello. So yeah, so this is like an open design meeting, and usually we start by just like giving a recap of major features that have been merged since the last meeting, which this time is a long list because it's been 2 months, and then talk about some of the in-progress PRs, some notable new issues that have been filed, and then just open discussion on like design topics. I have one big topic I want to cover this meeting, which is the layout framework, and then there's been a bunch of work on other stuff, so I will leave the floor open for that afterwards. So let me just start by going through some of the recent changes, some of which were, I guess, in November by now. But yeah, so now we have this new Moderath dialect, and I think we have basically completed the migration of all of our old dialects to using Moderath. So we have Moderath NTT lowerings, we have Moderath for coefficients in the polynomial dialect. I think that there may be some more, but there's now like passes using Moderath, so it's good. But I think one thing we are missing is like canonicalization patterns for it. So I know that's a topic on the agenda. So we have Wouter has been doing like a flurry of work on basically adding new CGGI passes to avoid the Yoast circuit optimizer, because programs of any reasonable size just slow to a crawl through Yoast because it's unrolling loops and stuff. And so he's working on this combination of like doing arithmetization of the circuit and also targeting the high-level TFHE Rust API, which is then going to their FPGA, the Belfort FPGA. We also now support Latigo. So we have a Latigo backend, we have lowerings for BGV, and we have end-to-end execution tests. And then Hongren has been doing a bunch of work on lowering all of the like client helper functions and stuff for Latigo. And I think CKKS has some stuff in there as well. We have a new Python front end. It is very, very, very rough. It can't do much right now, but it basically can take a Python program, run it through HEIR to compile the result, load in the shared object code, and then run the result directly from Python. So Alex, I think, is doing a bunch of work on improving that, and I will be jumping into that after I'm done with layout stuff. We have some improvements on the secretness analysis. I think these are mostly minor improvements, but we have been having more and more analysis passes that depend on saying, okay, only apply this operation or this analysis for a value that is known to be secret from the HEIR. Okay, so we have a whole bunch of work on improving the prettiness of the generated MLAR code. So now types will have like a value of a certain type will have a special variable name instead of just %0. Sorry. Okay. And then like ops, I think, will also suggest names for the variables for their results. So it basically just makes the IR a lot prettier. And then we have like attribute aliases and type aliases that get pulled out of the like main IR. So it kind of defines all the types up front and then uses them as aliases. So it makes the IR much prettier. We have proper support for cyclic repetition when we're doing like a default encoding in OpenFHE. We have new ciphertext management dialect, which represents the high-level ciphertext management operations like relinearization, mod switch, bootstrapping in a sort of mostly scheme-agnostic manner. And then there are new passes to insert them and optimize for them at the secret level before lowering to a particular scheme. Hongren had some nice PR showing how to use GraphViz to visualize the IR, and that got put on the front page or on the I think the getting started page or the tutorials page. Okay, yeah, oh yeah. So now we have like a formal framework for having one analysis that depends on the secretness analysis in such a way that if you mutate the IR, it will like rerun this secretness analysis to update all of the secret values, so you can have fresh data for that. We have merged a bunch of our passes that lower things to OpenFHE from different dialects into one big LWE to OpenFHE pass. I think we have completed the LWE type migration. There may be some old LWE, like old LWE dialect files still lying around that we can just delete at this point, but I think everything is using the new LWE types that have like, from that whole design process. I added a recent pass called drop unit dims, and this will canonicalize linear algebra ops to their specialized values. So if you have like matrix multiplication where like a matmul op where one of the matrices has a axis of size 1, then it will turn that into a matrix vector multiplication op. And then I added a new tensor X to convert layout op. So this is intended to basically change the packing of a ciphertext in the middle of the program. Okay, in progress, we have the type inference for Python frontend. So I think this is basically making it so that you can annotate the Python types of the function with like secret I16 and it will propagate that through. I think this may also have support for tensors. No.
It's coming. Give me a few more days. But actually, if you can let me screen share for a second, I think not many people have actually seen the Python front end in action. And I have it open, so I want to just quickly show like a simple demo. Is share now. What can I share? Window example.py. Yeah. So because I mean, this has been a lot of work from Jeremy, and then I did some type inference stuff on top of this. Are people seeing my picture?
Yes.
There we go. Cool. Yeah. And so if we
may want to zoom in a bit.
Yes. Increase editor font size like a lot, right?
Or I think you can also reduce the size of your window. And I think that
does this work for people?
Okay. Yeah, it's probably fine.
Cool. If people are seeing something, basically it's the thing I just posted as a screenshot, and just to show you what sort of happens. You can see this actually generates this input. You can get it with nice annotations here, and then you just mentioned Hongren edit this lovely graph visualization system, and so yes, I've actually just made it so.
So that's generated by the Python frontend.
Yeah, like I added a bunch of nice debug features after I was working on it, like this. This generates then some final output, which is this is using OpenFHE, so it will generate some ugly, horrible thing. But this is basically what you then interact with to actually run the program through all of these nice abstractions. And yeah, it works. It also supports CKKS now. It does not quite yet. So it also supports a few other things. It does like the correct plain text type inference, but it does not yet support tensors, because unfortunately tensors are sort of annoying in the Python thing that we use, because it doesn't have static shapes. So okay. Yeah, that's kind of the big limitation. So you can see annotated type MLIR. Oh, did I not?
So this is doing plain text ciphertext?
Yes, but it helps if you actually do the right, if you press Control X. So yeah, all of them turn to secret, so that's why the type of thing is a bit boring. But yeah, this will actually correctly emit ciphertext, plain text operations as well.
Cool.
Yeah, that's the current state of the Python frontend. I think I unfortunately didn't have time to clean up my PR, but I'll try to do that over the next couple of days so people can actually start playing with it. I think, Azra, you actually did start playing with it today, didn't you, or yesterday?
Oh, I was trying to play with it. I think I took an old state. I was mostly interested in the selective secret argument ability, so the annotation of the secret. But yeah, I think now there's some more, the subplane ones should work too. So that I also ran into that. I think just uncommenting one of those examples.
Yes, yeah, so it's really fun. I think the front end allows you to run into all the bugs of the compiler, all the missing features, much faster than you could ever run into it during normal handwritten MLAI exploration. So it's really great at finding bugs and finding missing features. But yeah, thanks. I'll speak to you, Jeremy.
Cool. Yep. So Hongren has been doing a bunch of work on parameter selection for OpenFHE, and I think there was a recent paper there on application-aware security. So basically, you have to know what your circuit looks like in order to select parameters. And the OpenFHE API has this like thing. Yeah. Okay. I don't want to get into the details too much, but Hongren was implementing basically the way that you're supposed to analyze the circuit to figure out what things to pass to the OpenFHE API to ensure that it generates secure parameters. Yeah, and I think there's more ongoing work on parameter selection that I don't think is pushed up to PRs yet that I haven't seen. I've been working on the layout selection framework. So this is basically generic packing system for the whole compiler. I'll talk about that more in a bit. Wouter has a whole bunch more passes that are in review on going this basically this FPGA CGGI path. And then I had a burst of energy the other day, and I started implementing the shift network. This is the like how you implement a packing change. And so the paper that I was based on was Yella's paper here on using graph coloring to like identify conflicts in like your power of two shifts. And so I implemented that, and there's still some things blocking it from being useful. Mostly we have some type issues that I can talk about later. We also had a new master's student who wanted to work on like polynomial evaluation optimization. So they did the first step of that and added a polynomial.eval op. And then internally in Google, we have someone who is working on the polynomial approximation solver that's going to go in the compiler. They basically did an implementation in Python. I have yet to play around with it, but I plan to port it to C++ when I have time. It's doing not quite a Remez solver, but something that is, according to him and his research, is basically as good for all intents and purposes. So we'll see about that. Okay, some notable new issues. So I filed an issue about lowering CGGI to OpenFHE's BinFHE because it's an obvious thing that we should do. But the other is because Raghav Malik published a preprint where he had already done this, and his code is in his repository somewhere, and he said he intends to clean it up and upstream it. And I think there's even a draft PR already that like an old draft PR that has like the first steps of this. But basically, I think we will. I filed it basically to tag him on it. Okay, so Alex had this thing about clear text intersemantics for the HEIR front end. Maybe we can leave that, talk about it during the open discussion. There's an issue about moving the cyclic repetition code that we wrote for OpenFHE that I think Hongren wrote to earlier in the pipeline to actually do it during the ciphertext packing part. And yes, I haven't gotten to the point where I can even think about how to do that yet, but that's definitely there. We have a list of debugging features from Alex, which I think you've already added some in your Python work. And then yesterday and last night, we were talking about the optimized relinearization issues. There is one issue where operation rebalancer was basically requiring, was not aware of ciphertext versus ciphertext, or not aware of the level. And so now there's this discussion going on there about like, do we even need to constrain the key basis dimension when doing multiplication ops? And it appears that we don't. So that will simplify that quite a bit. And then there's an issue about, so Hongren had this nice issue where he walked through doing a multi-layer perceptron for MNIST using HEIR's CKKS pipeline. And there's like a bunch of steps where he got blocked along the way and had to do like manual edits to the IR to make it so that he could keep going. I think this is like a great template for us to follow to basically iron out all the kinks and get everything working. So yeah, I encourage everyone to read through that. Okay, layout framework, great. So I have been going through this PR and studying all these other different layout frameworks and different compilers. And so I came up with this design, basically like, what are we going to use to represent a layout? And so I came up with this big design doc that we don't have to read through the whole thing, but the basic idea is, where is an example? Yeah, okay, so the basic idea is to use MLAR's affine map. So this was basically it's an attribute that MLAR has that they use to represent how a tensor might be tiled across memory. So they use it literally for the same thing, but just for smaller registers than ciphertexts have. So they'll use it for like vector registers on the TPU or whatnot, or GPU stuff. And basically what it is it is a map from dimension indices to some expression. And it doesn't say how to interpret the expressions. It just says like, here's the operations you're allowed to use. So you can do any affine thing, and then you get the extra operations: mod, ceiling division, and floor division. And these are, they call this quasi-affine. But the point is that you can use this to, so here's the examples from upstream MLIR. You can have like a tiled layout of an m by n matrix stored with 64 by 64 tiles, and then you define it sort of in this way. And I figured out like what I did was I went through the tile tensors paper and the Felipe paper, and I looked at their notations, which was, it's very funny because they both claim that their notations are strict generalizations of each other. So one of them is wrong, but I didn't bother to figure out who. But the point is that I was able to determine that affine map is more general than all of theirs. Basically, all of each of theirs has like a general formula for like what their notation means, and that formula only uses quasi-affine operations. So, we have quasi-affine operations, and we can just directly implement their formulas. But yeah, so here's like what the like generic tile tensor thing looks like this, and the generic Felipe thing looks like this. And so, okay, I say, let's not use either of those notations. Let's just use the affine map. It's already implemented, and it already has all these nice functions associated with it. Okay. Then what I did was I went through and I said, okay, here's all of the ops from the Felipe paper. They give this like tensor language, which basically just has like tensor primitives, and then they describe how the ciphertext layout changes as it goes through each of these operations. And then what they do is they implement like matrix vector multiplication in terms of like a combination of these operations. The downside is that they don't do like Halevi-Shoup or any clever thing like that. They just do basically like row-wise and column-wise things with striding and that sort of thing. And then they have like ciphertext packing to like recompactify when things get too strided. But basically I went through and said, okay, what would the formulas for affine map look like for each of these if it went through? And so, okay, you can read through that later if you want. Point is, I convinced myself that this was fine. So then I wrote up a PR that just does like kind of the minimal to convince me that it actually does what I led myself to believe it does by writing that doc. And then it does like sort of the first half of the Felipe paper. So what it does is it basically says for each tensor that's secret in the IR, assign to it a layout attribute as an affine map. It starts by taking all the function arguments and assuming that they're just row major packed into a single ciphertext, which is already a little bit too limited because we want to be able to go over multiple ciphertexts, but I'm ignoring that for the moment. Then it forward propagates the layout attributes through the IR, applying the relevant transformation as it goes through the ops. And then if it encounters an op that has two operands with incompatible layouts, it will insert layout conversion operations to just make them all agree and then continue. And then it persists that data on the IR. And so this kind of allows me to, okay, so here's like one example. This is a little bit too small. So here, there's one where basically you have 2x2 matrix that's two 2x2 matrices. Both of them are row major packed to start. You sum along the rows of one and you sum along the columns of the other. And so that produces one vector that's strided and one vector that's not strided. And then if you want to add those together, you can't do that, right? Because they're packed differently and the slots aren't aligned. So it implements inserts a convert layout op that converts so that they're both this compacted version, and then it adds them together and returns it. So this, the weird thing is I added this tensor x.sum op that I would like to remove. I just wanted to pick something that was similar to Felipe and simple enough that I could use it to convince people that this is the right approach. In reality, there's a linalg.reduce op that does like general reductions by any operation that I think would be the right thing to do there. But then another one is Halevi-Shoup. So here we have Halevi-Shoup, and this is so yeah, I took one of the existing test cases where it was doing, instead of matrix vector multiplication, it was doing vector matrix multiplication, so things are just transposed. But now we have the layout ops basically propagating through like collapse shape, which will remove a dimension, index of, or an axis of size 1, and then expand shape. So there's like all these things you can do to the tensors, and the layouts will propagate through them nicely. Okay, so the kind of open questions that I wanted to discuss, I mean, the biggest open question I wanted to discuss is like, how are we going to actually, like, so, okay, so in order to do layout propagation through the IR, you need to know how you're going to lower the ops. So you need to know, am I going to do Halevi-Shoup, or am I going to do the naive matrix vector multiplication, or am I going to do something else entirely? And if you don't know what kernel you're going to use, you can't even like propagate the layout through the op without, and later what I want to do is I want to have like a backwards propagation that basically says, take these convert layout operations and like push them backwards through the IR and see if you can get them to go all the way back to like the function arguments. And then at that point you say, oh, this is a function argument. It starts row major packed, and the first thing I do is convert the packing. I'm just going to pack it from, move that packing change to the client side and have them encrypt something different. But yeah, I can't even do that step if I can't forward propagate or backward propagate the layouts through the IR. So this is kind of the big question, is like even if we're like, there is a deeper question, how do we like optimize the joint choice of like what kernel to use and when and where to do layout conversions? But even before that question, it's like, how do we even do the analysis if we don't know what kernels exist, or which of the kernels we're going to use? And okay, the last thing I say before I open the floor to discussion is, every compiler paper I've looked at so far just picks a packing and they say this is the best packing, and that's how they enable all their other stuff. Is they say, this is the packing we're going to use, or when they're optimizing, they like do a brute force search over all possible packings, or they have a heuristic, and then they say, okay, I'm going to fix this packing and then like assume I know all my kernels, and then like use that to decide like what to do, or like how good my packing was. So basically everybody has like a static choice of kernel, and this would be like new research, basically. How do you jointly optimize for the choice of a packing kernel with the decision about how to pack things throughout the IR? Okay, any thoughts? Does anyone have any like objections to doing things this way to start, like using the affine map and like having like this forward propagation? Okay. It seems I've convinced everyone. Okay,
But
well,
what I was thinking about is, can we define a metric for like what kind of kernel that we want to use for doing matrix vector optimizations? Are there specific examples where we want to go for Halevi-Shoup, or do we want to go for, I'm now thinking the Orion Brian Reagan matrix multiplication thingy? Are there examples that we really want to define what kind of kernel that we want to do based on the example?
In the Orion paper, they take convolution and they represent it as Halevi-Shoup, or some tweak on Halevi-Shoup matrix multiplication, right? Like I think it's like a block Halevi-Shoup thing. But like I don't know. I haven't seen anybody like actually try to compare. Like, okay, say I do Halevi-Shoup and that requires me to like do extra ciphertext packing management operations versus not doing Halevi-Shoup and not having to do those like repackings. I haven't seen like a comparison of that. I've just seen every paper that uses Halevi-Shoup says Halevi-Shoup is the greatest and will only do this. And the Felipe paper, and I think the tile tensors paper, those both can't do Halevi Shoop, but they do their own thing, and they don't even consider Halevi Shoop.
I
So
think
I don't know.
I think Edwards is the only one that I know that does that, and he builds like an ILP off of like a set number of different kernels to use, and
Okay.
then the cost is based on maybe like you can have like a depth constraint on it, but he'll build the cost out of like the adds, multiplications, and rotations for each of the types of kernels.
Mm-hmm. But then he has to track like the layout choices through. Okay, I would have to see what his ILP looks like, because that sounds, I mean, that sounds up my alley. I love ILPs. But yeah, I think having like a cost model, at least a heuristic cost model for each possible kernel for each op, and then having like a cost for each layout conversion, because that was like kind of like a known expense. Yeah, go ahead, Yala.
I wanted to say that I think the packing method that is best also depends on how much space you have in your ciphertext, right? Some of them like replicate values already. And so I'm not sure if that's information you have at the time of compiling.
So it is, but I'm kind of copping out, because we do at some point want the compiler to decide what the ciphertext dimension is, in some sense, or it may be constrained by the particular hardware that you're targeting. So right now what I do is I just have it pass as a compiler flag, like, and that's just like from the beginning. I think you have to pass like a ciphertext dimension flag, and then that is available during the pass. But yeah, you're right. If you have ciphertext that are too small and you need to pack your thing among more ciphertexts, or you're sort of wasting ciphertext space, then that could affect the packing, definitely.
Yeah, and there are also, some of these methods essentially take up more space because they replicate the like the matrix. So
that's what we do. Yeah, we in all of our tests, we basically by default replicate just repeat it, so that we can do like rotations. Okay. I mean, the other, if there's no other, yeah, I mean, I would love to, collaborate with anyone on this and turn it into like a research project. I think that would be really interesting. I need to get something working before March, so that we can go to our presentations and say, look, we have ciphertext packing. So what I will probably do is I will probably just say Halevi Shoop for all matrix vector multiplications, and then like just force that, and then do it otherwise Felipe style, forward propagate, backward propagate, and then go from there. Yeah, Alex.
Since we know we're going to want to do some optimization passes later anyway, how about we split this into a pass that labels all the things that are sort of difficult to forward through with some attribute, right? Like to what happens internally. That could just be like, it goes from this map to this map. It could be something more complicated. It could be as simple as like Halevi Shoop, but then you have to have like a list of them, right? But I think the point is that if we have this pass, then for now we can just have really simple implementations of that pass, but we can also then reuse the propagation thing, because I have a feeling a lot of the optimization things probably don't want to deal with the nitty-gritty of like ensuring consistency throughout the whole IR, right?
Yeah.
Similar to, for example, we do a lot of the ciphertext noise management now at the like secret arithmetic level rather than at the like scheme level. I have a feeling we might end up doing a lot of the like optimization at this very high level as well, where we just tag, let's say, a lineage.matmul, but long before we even have all of the final ops that need, a layout assignment.
Right.
And so maybe this is the easiest way to do it right now, and to stay flexible, is to split it into basically like an annotation pass that like is the optimizer, even if the optimizer currently is just always do it this way.
Yeah, I mean, right now the pass that I have in that PR is basically just annotate the IR and don't make any serious decisions. And so I was thinking that like it would be good to separate that from the optimization step. But yeah, having any kind of forward propagation is not possible unless you know which kernel you're picking. But yeah, it could be like annotate it with a list of like supported kernels and then with a selected kernel kind of thing. So it could be like, Matt Vec-Mull has naive and Halevi Shoop, and then selected is Halevi Shoop, and then that will be like, if you want to like redo it. I don't know, maybe.
I was actually more thinking like before you do the forward propagation, right? You basically say this lineage.matmul operation will be using Halevi Shoop, right? And then in the forward propagation pass, you accept this as like word from God, and you just make.
Oh
it work.
yeah, I see.
Because I think
Yeah,
that's
so it's like a kernel selector, basically.
Yeah, like a
lineage
kernel selector pass that just annotates right now every matmul with HEIR or something, right? But later on could do some complicated optimization, but then doesn't necessarily have to deal with all of the like fiddly bits, right?
Yeah, that's a good point.
Because I'm also thinking that would actually work really well with like front end hints and annotations as well. Like you could maybe like decorate or like annotate with like a named type hint or something, your like Python matmul. And then that would tell us that like this, not just like the matmul function itself, but like this specific matmul on like line 7 in your program should use this kernel. Because I have a feeling that, especially in the beginning, as we don't actually implement optimization, I assume most people want to do some manual control from the front end. And this way it might be fairly easy to like sort of communicate that through, right? Because we could already have the front end annotate this kernel selection.
Right. It could be like secret I16 comma, or like, you know, whatever, tensor I16 comma like hint, right? And you could like add it as like an optional thing for the secret.
Yeah, I guess it would actually be part of the tensor, but yeah.
Yeah, well, okay, well that was another like minor question I had, is that like I was thinking of like materializing the layout as like an attribute on secret, and that's what's in the PR right now, but then I don't actually materialize it. I just leave it on the ops. And so I could either put it on the secret and then use that during type conversion, or I could have this like op-aware type converter system that we started using to do that. So I haven't really decided on that, but yeah, that's just why I was thinking of putting it on the secret.
Oh, yeah, sure.
Yeah, the other thing I ran into is when I was actually implementing the layout conversion op, we have this mismatch in abstraction where TensorX is like working on actual like data tensors, but when you lower convert layout, it's like you want to lower convert layout conversion into a series of rotation ops on the underlying ciphertexts, right? But we at that level we only have like tensors that are like data tensors. So you could have like basically a two-dimensional matrix, right? And then if you do a convert layout on that, you can change the layout string, but then how do you actually, like, what does a rotate mean on the two-dimensional tensor, right? Like it could mean something, but it does not mean rotate the ciphertext underneath the tensor, right? So I might need a new op that is like rotate packed, something like that. But I'm not, yeah, it's like I'm a little confused about how to deal with this.
This is a really good question, because I think this gets to the like semantics of the HEIR, right? Because I think it's very clear that I mean, to answer the question that came out above, like about the like integer arithmetic like semantics, I think we're very much leaning towards you can pretend that if you specify I16 and your program doesn't have any overflows, it will behave as if it was I16. Practically, the plaintext modules will be larger than like 2 to the 16 or something, right? I think the same thing is sort of true for the tensors, right? We have this point where we definitely want people to pretend that tensors are real and can have any size, any shape, whatever. But then eventually, you're right, this does come this point where we have to say, no, this is now like a packed ciphertext. It can only have one specific shape, and it has that one dimension or like two, whatever, depending on your packing scheme. I think the way that like the HEIR implementation, like the matching optimizing currently does it, is sort of dirty, right? Because it mixes these abstractions. And so maybe this is what's showing up here, is that like this should be a pass that sort of does a type conversion to something. But then the problem is then we can't use all of the like ops that we would like to use, right?
Yeah, I mean, I think there's some step at which I need to convert multidimensional tensors to single dimensional tensors, where or convert them in such a way that like maybe this is just like using the layout, like it needs to probably happen at the same time the layout conversion, but like using the layout, you basically say, okay, this whatever 64 by 64 matrix now becomes a 3 by 65 532 matrix tensor that corresponds, where this last index corresponds to the actual ciphertext dimension, and then
I think there should be a point where a convert layout takes a tensor of like type T and outputs the exact same type, right? Where it's literally just an annotation in the the high level program that still operates.
Well, that's what it is.
Right?
That's what it
And
is today. Yeah.
All of this, I would expect that we then go, and I think we might have to, just for practicality, abuse the same tensor type, but we can sort of think about it as like high-level tensor and like ciphertext stand-in tensor, right? Where we actually say, okay, now after this pass, all of the tensors, like their last dimension is like ciphertext degree, right?
And then you don't need a layout string anymore.
And now, like they're like directly corresponding to the ciphertext, like right. Like if they have multiple dimension, that means you have like a matrix of ciphertext, right? Or like of polynomials at least. So I think that would be. I think unfortunately we're going to have to call both of these just tensor or like tensor type because.
Right, it's the same. It's the same type, right? But
there will be like a semantic switch where like after a certain pass, tensor 3 by 16K. Doesn't mean, oh, this is like a matrix of with weird shape. This is 3 ciphertexts or 3 polynomials, right? And so it's a bit unfortunate that we can't make it more clear in the IR, but I think it will be fairly obvious from the fact that everything will be like last dimension 16K, right?
Yeah, I mean, we could add an attribute on the tensor, like for its, there's like that free arbitrary
we
attribute.
can just add the LWE encode packing attribute. Like the full CRP packing or something, and that makes it super obvious.
Right. Okay. Yeah, I'll look into that because I think that this is like we just have been ignoring this and we've just been saying, oh, the high level data tensor is the ciphertext size, right, already, and so like we're not like abstracting anything from the user, and this is the first point at which I've kind of like we have to do something. Okay. I will have to leave in 5 minutes, so I will be done. Thank you everybody for hearing my rants and sharing your thoughts about layouts. Please contact me if you want to do some layout optimization research. But yeah, let's move on to Python front end. I think Alex, you already showed this. Is there anything that you are blocked on or need help with?
No, I think the type inference I can probably do myself. It's probably going to be a couple of days before I can get something working, and then clean it up. But no, I think the big blocking factor in some sense is tensors and their shapes. Like now thinking data tensors, right? It's just that number considers everything to be an array of like dynamic size. We don't want that. Or it considers everything to be a tensor of dynamic size. This creates perfectly valid MLIR. It's just that our compiler doesn't deal with what in MLIR is like question mark by question mark by I32, right? Like we don't support in any of the FHE pipelines dynamically shaped tensors because it doesn't make sense in FHE where everything is like data oblivious and statically known. And so that's like the biggest part for me is actually just implementing type inference. But right now, as you can maybe tell from the little demo I gave, I've actually been doing a lot of work on user friendliness, like pretty typed annotations with Python type hints, doing a lot of work on like making it a bit more robust. So I'm obviously motivated by implementing like the Heracles backend. I just literally like made it so that you can select something other than OpenFHE, but it obviously doesn't yet have like the magic Python integration where you can then actually call it from Python. And so I think there's a couple of sort of like refactorings that are necessary. Some of them actually leaking out of the Python frontend. One of them I mentioned on Discord, which is I really want to get rid of the scheme flag in the HEIR translate OpenFHE emitter. I thought that was really easy, but it turns out there's one annoying part in like the preamble of the header where you have to like select the scheme in like the OpenFHE thing. My current solution for this is to just, for the moment, throw a like OpenFHE scheme attribute on the module. Would be my suggestion.
Could you, in the same way that you can look at the LWE ciphertext type, can you like no, you can't walk through.
The problem is I think I need to know this basically, I guess I could like look for a function and then hope it has a type somewhere that has the right thing. But like it would be like, it would be really fragile. So I think the best thing is when you lower from like BGV or CTKS to OpenFHE, you just add a pattern that just takes the module up and slaps on that like what you just did thing. I think long term what we want is like a full block of things, like an operation with a region that contains a bunch of parameters as attributes or ops or something to actually specify, hey, these are the parameters, because right now a lot of that lives in the type system or just lives in like attributes and things. So I think maybe what we want at some point is like hey, this module is operating relative to this, because one of the cool things we could do in OpenFHE is actually emit mixed scheme backends. But that would mean that we would have to change the whole emitter to like track a specific context rather than just, so like there's a,
that's a big amount of work.
The quick and dirty thing I'm going to do is just throw a scheme info somewhere. But then the other one is I would like to rework some of the pipelines, how they're grouped. Instead of having it be like MLIR to BGB or MLIR to OpenFHE BGB, it would be really great if we had MLIR to BGB, period, like and then to OpenFHE as a separate pipeline, because it just makes it like, we can work around this, but it just looks really ugly in the like front end, because there's like like if you have this backend, then you need to actually do the different thing, right? And so this is a fairly minor thing. It just probably touches a lot of test files and nothing else really. It just changes the command line parameters. And it just means that instead of like calling a single thing, the default will be to call two things, one to specify like the front end part, one to specify the back end part. Since I assume most people will be using the front end in the future anyway, this shouldn't even be like exposed to people in the future, right?
I have to drop, but great talking to everybody. You guys feel free to keep going. Right. Bye.
Thanks for joining. So I think that's basically all. That's what you want to share.
Yeah, I can.
That's it. Like on the Python front end. Otherwise, some of the big limitations, obviously, I think we haven't talked about these maybe in this meeting, is that because we're intercepting bytecode, we don't get control flow nicely. So currently, we don't really do control flow. So you can't write a Python for loop and have it be a nice for loop. So this is something where we can probably emit some like, low-level control flow, like go-to style control flow from the bytecode, but that's not very useful for the rest of the pipeline. So this is just one of the limitations. I don't think it's super important for the moment, because we can probably reconstruct basic like range and for loop kind of things by erasing, but it will just take a lot of work. And currently, I'm not focusing on that because the kind of examples that people are asking me for don't really do much of that. What people really want to see, and this is funny because it links back to the layout thing, they really want to see map modes and stuff, right? And the problem is, right now I have this sort of magic because we're saying, oh yeah, it would totally work except for, the whole like type inference thing. But as we just heard, right, we actually have this sort of hidden technical debt in the compiler of multi-dimensional tensor stuff being very wonky. And so I think for the front end to do something interesting for people, our like multi-dimensional tensor support needs to be much better, because the kind of things most people want to do in Python isn't writing a like bunch of manual arithmetic code, it's writing some NumPy calls, right? And so we can totally support NumPy functions in the sense that we just need to tell like the front end what the corresponding MLIR code needs to be. So if there is for example, numpy.matmul, we can translate to lineage.matmul, and that's fine. That probably doesn't support all different magic things. It doesn't support every possible NumPy thing, right? But it gives us a broad support for all of the things that like Lineage has in MLIR. The problem is then the rest of the compiler doesn't necessarily have great support for most of these, at least not in the arithmetic thing. And I think that's maybe the final point, is that currently the front end only deals with CKKS BGB / BFE, I guess, because we sort of treat them the same way, right? But we don't really have a BFE implementation. I guess, you can change a letter in the OpenFHE emitter and it will be a BFE implementation. So yeah, I think adding support for the like CGGI pipeline would be really, really interesting. But I don't know enough about it to see how that would work. So maybe Azra, that's something we can like sit together tomorrow or next week and try and brainstorm.
Yeah, I was actually, for my own purposes, I want to create some demos with the Python front end to CGI backends. Right now, I am mostly interested in using the Python front end to generate the standard MLIR code that I can pass into our CGI pipelines. But you should expect me to be tackling this sometime late February, at least to integrate something. But yeah, I agree. I think part of it might be that we want to do the non-Yosis passes.
Definitely.
It really depends. Yeah. So part of it is I don't really even want to bother doing that until we can get good examples like matmul's lowered without taking multiple days.
Yeah.
I think like
Go ahead.
the going to CGGI would be rather straightforward because you just want to unloop everything. You just want all of your arithmetic specific operations, and that's it. And from that point on, you can go Yosis, you can go non-Yosis, but
I think I think the actual
it's
low end part, the HEIR op part, should be fairly straightforward. I actually just added, it's untested, but I just pushed it. I just added before the meeting the feature to like specify your own like command line pipeline arcs to the decorator, so you can use the Python front end also to play around with like testing, which I think is going to be useful for us in like internal debugging uses, right? You can sort of say like, hey, instead of doing the like MLIR to BGD, MLIR to CTS thing, just run these things, right? Because that's what I end up doing manually from the input anyway. And I figured like it's easy to support in the front end. I think in general, I want to move us towards the point where actually you run most of the things through Python when you're developing. One of the things that would be really cool that I don't want to do, but that's maybe Jeremy or Ezra can do, is I would love to have a version of the Python frontend that doesn't just call the binary, but calls Bazel run, so that it automatically compiles in any C++ changes. So that you have like a developer mode where instead of just calling HEIR opt, it will say Bazel run HEIR opt, because then I don't have to like, I had a debugging phase today that took me 10 minutes to realize, oh, the bug doesn't disappear because it was a C++ bug. I fixed it, but forgot to recompile the tools, right? So yeah, I think I'm really like, as I'm sort of dogfooding the front end a lot, it does have a lot of potential to make the development experience nicer. And then I think the part that's hard about the CGI stuff is like actually doing the like backend integration for, let's say, TFH ERS, right? Because
Yeah, I think
it's not going to be using the same PyBind stuff that the C++ stuff uses.
even then, like the straightforward part is that we can still omit the code, and it might not have that same like nicety of being able to just like call directly with Python. But also for like, I mean, for each of the hardware accelerators, it's going to be somewhat difficult to get like custom Python front end integrations. But yeah, I think I will probably be exploring this sometime before Real World Crypto.
Yeah, I mean, currently the Intel version emits a CSV file in like the debug folder for like the Intel backend, right? Like that's how far I got. And then it's like, well, actually, then it's like the whole like the SDK that we currently have isn't really designed to run things like a real application. It's designed to like test things and verify them. And so I would assume that a lot of the hardware vendors have similar issues where like, even if you build the front end perfectly, a lot of the SDK stuff isn't really designed to actually like run applications and get results. It's designed to like put in a bunch of test vectors in a circuit and verify that it gets the like same result and stuff like that. So yeah, I think I'll be exploring this with Heracles. I will hopefully in a week or so be able to push like an early version of that as a draft PR, but I don't expect to be able to merge that until much more progress has been made on the SDK side for the accelerator.
Agree. Yeah. I'll be making some work upstream on the CGI front as well. I also realized that one of these issues at LW type migration just hasn't been done for CGI, likewise with some of the secretize improvements. So that was also on my plate. Also, on CGI past progress, not to belabor Voucher into giving this update like for the 100th time this week. So I'll like briefly describe some things if there's anything you want to call out. But for like non-Yosis paths, there's a path from like arithmetic, or I guess really TOSA or arithmetic standard MLAR to high level like F32-bit TFHE REST API, and then also yes, another one from TOSA or Arith that then goes to like chunked lower precision, like for 8-bit chunks. And that work is being done TBD to optimize these properly and also go down further to the PBS levels.
Yes. Yeah, for now, also finding somewhat more parallelization across once we're at the TFHE, well, once we're at the CGGI 32-bit level, find some parallelization on that part as well. or keep the parallelization that is given by the TOSA models, but that's something that that we're figuring out along the way.
Right, right. There's, I think one of the passes, you can lower to parallel for loops if you kept the for loops in. There should be
well,
right, an affine parallelized pass. And then I think Hongren is here.
Yeah.
Added
So
this bullet point.
I gave an issue on the baseline, so I think the baseline is OpenFHE parameter selection, and I had some branch that analyze that, but didn't get it to upstream because I'm having vacation, so I might be slow on this.
Well, enjoy your vacation.
So I heard that AISEC is having similar things, and they have taken my PR to do their work, and I want to know about their progress. So
Yeah, I think Mark and Martin might be here. Christoph is not, I think. Oh, actually, maybe they have left. Okay, Mark is here.
Hi, yeah, I'm here. So Christoph used your, thanks again for all the work, because it really helped to get started with this stuff. And Christoph started using your UPR to add the arrow bounds from the Mono paper, and we're trying to so he had the first rough prototype where he said that it actually seems to work, and the first things that he tried to compile the example with the dot product that actually got him better parameters than if you didn't use it, or if you didn't use the monobounds. And it's around in the range that the Mono paper claimed that how much better the parameters would be, but it's as I said, it's a little bit rough prototype, and he's trying to put it in a better shape currently.
okay, very glad to hear that.
Fortunately, if you are interested in parameter selection, we can add you to the Discord sub chat between ISEC and Hongren if you want to make sure you're not stepping on people's toes. Otherwise, also, I mean, just chat in Discord if there's anything that you're curious about, who's working on something, or if something is being worked on. But I think you relatively will know that, you know, Python frontend is Alex and Jeremy, and CGI pass is Wouter and to some degree me. And then layout framework is Jeremy plus anyone he wants to get to help with this. So you should have some kind of like contact point thing. Just feel free to message in the Discord. Any other last minute things in our last 2 to 3 minutes? Questions? Someone being like, hey, I just want a random issue, or what's going on with XYZ?
More like questions regarding to the CGGI lower down to the OpenFHE pass. So is there any estimations?
Estimation for like when that would be done?
Yes.
Okay, so have you seen Rogov's paper? I can link it in this notes. He has this preliminary paper out for built on this work. I think it's just a preprint right now. I will drop it in these notes when I get a chance. I think just go ahead and message him on Discord. He's active on our Discord. Or actually, Shuhao, are you on the Discord? I can just send you to a DM.
Yeah, the FHE org Discord.
Okay, let me just send you to a message, and you can ask him what his timeline is to upstream it. But I'm pretty sure it's in his fork of like his HEIR fork that he wrote for the paper. So maybe it's probably somewhat easy to just port yourself if you're curious and doing it faster.
Great, great. Yeah, that would be wonderful. Thank you.
Yeah, I will try to find you. Okay, found you at least, and so I'll send you to a message. Any other things? All right, in that case, we will see you all at the next meeting, and then feel free to chat with us on Discord or otherwise. All right,
Okay.
Thanks.
see
Bye.
you.
Thank you. Bye.